Welcome back. Now we will see delta connection. We will see what is the relation between line voltage and phase voltage, and also line currents and phase currents with the help of phasor diagram. But before that, let's have a look at delta connection. What actually delta connection is? Delta connection is also mentioned as mesh connection in some of the books. Here in this connection, I'm showing this is, I'll take this one as one phase, A1, A2, and this is another one, B1, B2, and this is another one, C1 and C2. And these are the joints. Now if you see, the finished terminal of one winding is connected to the star terminal of the other phase. See, A2 is connected to B1. Similarly, B2 is connected to C1. Similarly, C2 is connected to A1. Now the three line connectors, they run from the three junctions of the mesh connection, and we call these as line conductors. And most importantly, you see there is no common points, or what we call it as a star point or a neutral point. Everything is a junction type of structure here. So this is your representation, and the voltage across this individual phase, we call it as phase voltage. And see, the same voltage is the voltage which is there across these lines also. That's why in a delta connection, line voltage and phase voltage are same. Both in magnitude and also in phase angle. Both in magnitude and phase angle. See, once again, the voltage across these 2 points, which we call it as a phase voltage, is the same as the voltage across the main lines, line voltage. So that's why I am taking this line voltage and phase voltage are same, both in magnitude and also in phase angle. But see the currents now. See, this is your line current which is flowing in this main lines. See, these are the phase currents which are flowing here. Now, can I say that this phase current is equal to line current? No. At this point, see, there is a combination of 3 currents here. This is one current, this is another current, this is another current, which means that line current and phase current are not same. Line current and phase current are not same. But whereas line voltage and phase voltage are same in case of delta connection. This is quite opposite what we have seen in star connection. So, to obtain the delta connections, what we should do? The end of first coil must be connected to the start of another one. Similarly, the end is connected to the start of another one. Similarly, like this. The 3 junctions which we do have, A2B1 and B2C1 and C2A1. And at these junctions, we will run the live wires and we call them as line conductors. And the current flowing through each phase is called as phase current, whereas current going through each line is called as line conductor. Similarly, the phase voltage is the voltage across each phase, and the voltage across the lines is called as line voltage. Now, if you carefully see, as already I mentioned, in a delta connected circuit, VL, which is nothing but a line voltage, is equal to the phase voltage. This is an important thing which you should remember. But whereas for the currents, it is not the same. So if I take this one here, see, line currents are not the same as the phase currents. Now let us take the phase currents at this thing. See. Now I'll take this one as RYP. Now this is RY, IRY. This is IYB. And this is IBR. And I'll take this one as IR currents. See, both are not same, right? So at this junction, if you carefully see, IR is equal to, see, at this point, I'll apply KCL here. Sum of all incoming currents is equal to outgoing currents. How many incoming currents are there? IR and IBR. Isn't it? So what is IR now for me? It is IRY minus IBR. So this is the way how we get the currents. Okay. Now the phase currents, they'll be equal in magnitude, whereas the line currents also will be equal in magnitude, but their angles will be separated by 120 degrees if it is a balanced system. Okay. So now what is IR now? It is IRY minus IBR, right? Now let's draw a phasor diagram for this one. Okay. So I'll take, this is IRY. This is my phase current at an angle of 0. This is my IYB, which is nothing but I phase at an angle of minus 120. And this is my IBR at an angle of minus 240. So what I got, IR is equal to, it is IRY minus IBR. So in that case, see, this is IBR. I am getting it back. Earlier it was, the angle was 120. Now if I get it back, this is 60, right? So if I join these two, this is my IR. So what is the angle between these things? It is 30 degrees. Okay. Similarly, if I want IY, what I should do? IYB minus IRY. Right. So which means that my current will be, this is my IY. Similarly, this is my IB. Now if you see, similarly, again, I may get a magnitude. See, these two vectors are equal, IRY and IBR. They both have a magnitude of I phase. So this is minus IBR. It is having the same magnitude, but the angle is minus 60. Right. See, the magnitudes are same, but they are separated by an angle of minus 60. So we have seen it in the last case. So its magnitude will be root 3 V phase. Sorry, root 3 I phase, right? This is I phase. So root 3 I phase. We can go through this one. V is A square plus B square plus 2AB cos theta. Magnitude of the resultant vector. You can substitute it, you will get here. This is I phase square plus I phase square plus 2 I phase into cos 60. You will get root 3 I phase. You will get root 3 I phase. So that's why I have written the magnitude is root 3 I phase. See the angle here. If it is 0, I am getting an angle of minus 30. Earlier in voltage, in the star connection, I got plus 30. Now I am getting minus 30. So that's why, do remember, line current magnitude is root 3 times of phase current, which means mod IL is equal to root 3 I phase. But angle's point of view, line currents lag phase currents by 30 degrees. This is the most important thing. Okay. Now, I'll make a quick difference between star and delta. How is star? This is delta. In star, there is a neutral point. Right. In delta, there is no neutral. Right. In star, VL magnitude is root 3 times of V phase. And line voltages, the lead phase voltage by 30 degrees. See, this is leading. This is magnitude, this is angle. And IL. Okay. Magnitudes and also angles. Which means IL is equal to I phase. Okay. Now whereas here, in this one delta connection, VL is equal to V phase. Both angle and magnitude. which means VL magnitude is equal to V phase magnitude. VL angle is equal to V phase angle. But whereas currents, IL magnitude is root 3 I phase. The angle of IL is I phase minus 30. Angle of I phase minus 30. Which means line currents, the lag phase currents by 30 degrees. This is an important thing which you should remember. Okay, and see here, this is the delta connection which I have tried to draw it for you. Okay, now, yeah, this is all what I have explained. See here, line currents are 120 degrees apart from each other, but are 30 degrees behind that of their respective phase currents. And similarly, the active power equation, it remains the same. Here, I'll shift this root 3 to here, root 3 I phase. See, this one is IL, right? This one is defaultly VL. So I'll get root 3 VL IL plus 4. So the equation remains same, whether it is star connection or delta connection. This is reactive power. Root 3 VL IL sin phi. See, this is line voltage RMS value, not peak value. Try to remember. Line voltage RMS value. This is complex power. Okay, the units are, this is watts, this is VAR, and this is VA. And remember, phi is the angle between phase voltage and phase currents. Phase voltage and phase currents. Okay. Now the key things to remember, line currents are 120 degrees apart from each other. Phase currents are also apart from each other. Line currents are 30 degrees behind of their respective phase currents. Line current magnitude is root 3 times that of phase current. Whereas line voltage and phase voltage, they are the same. Okay. With this, I hope you have understood the voltage and current relations between line and phase quantities in star and delta connected networks. So try to practice all these things. These are the theory questions. See, derive the relationship between line voltage and phase voltage with the help of star diagram in both star and delta connected circuits. Try to practice it. Try to practice drawing the phasor diagrams and getting the resultant vectors using them. Okay. Thank you. In the next lecture, we will solve problems on this 3-phase star and delta connections.